It is an exciting yet challenging time to be in the industrial machinery industry. While the global market for industrial machinery is on the path of recovery and is projected to continue to post steady growth, estimated to reach $514 billion by 2015, it is still an industry under pressure. Industrial machinery manufacturers face pressure to improve the speed and efficiency of their product design and engineering so that they can reduce delivery time and increase profit margins. Their success can be achieved by more efficient, high-performing machinery that enables faster time to market and can adapt to the inevitable project changes from dynamic customer demands. Some of the best companies in the industrial machinery sector are building new capabilities and leveraging technology to thrive in this competitive business environment. During this webinar entitled Accelerate Machine Design, we'll show you how they are achieving their goals. Hello, my name is Cecil Pruitt with Spatial Integrated Systems, your value-added Siemens engineering software reseller for the East Coast and federal markets. I'll be your host, and thank you for joining us today. Here's a quick look at the agenda for today's webinar. We'll start by briefly reviewing recent industry trends, their implications of challenges placed in the industrial machinery industry. Then we'll identify key capabilities that the best industrial machining companies exhibit. This may be an opportunity for you to assess your own organization's current strengths and weaknesses. We'll also provide some success stories illustrating how companies are using engineering software tools to enable these capabilities, to improve and to grow their businesses. Let's begin with some input cost trends. Input costs that include raw materials and energy are on the rise and difficult to predict. Instability in energy and raw material costs lead to inaccurate cost forecasting and is a threat to contract margin and business profit. Machinery manufacturers are challenged to optimize the machine design process to minimize these costs. Increasingly, regulatory compliance and customer demand mandate that machine tool builders make their machines as energy efficient and safe as possible. So there must be an ability to design, model, and simulate this efficiency and safety before the machine is commissioned. Profit margins in industrial machinery are naturally small, as there are 85,000 plus machine tool builders in the world, including many in-house machine tool groups within this industry. This tremendous competition and the price pressure faced by traditional industrial machinery strongholds like Germany and Italy, and from rapidly growing countries like China, force machine tool builders to operate as lean as possible. Designing lean is mandatory for survival. Governmental regulations in the industrial machinery industry are influencing equipment design more than ever. Adding to that, rising consumer awareness and attitudes surrounding product safety are an increasing litigation risk. Industrial machinery companies need to apply strong corporate governance within the design and manufacturing process to ensure that the equipment they deliver meets all relevant industry standards on cleanliness, hygiene, and worker safety. No longer is it good enough to just produce average equipment. The game has changed, and the industry is demanding lean, clean, and safe machine design. Finally, environmental concerns are placing a greater focus on packaging recyclability and industry usage. This increased awareness is driving manufacturers and producers to pass on these requirements to their suppliers, placing new design requirements on equipment makers. These trends require equipment manufacturers to design customized machines faster. Industrial machinery companies are now demanding a better way to provide visualization of these customized products for sales and marketing, along with estimated energy consumption before equipment is ever built. No longer is it good enough to just produce average equipment. The game has changed, and the industry is demanding lean, clean, and safe machine design. If you're facing these pressures and more, you're not alone. To help you see how companies are maximizing market opportunities, let's look at an industrial machinery equipment leader, MJC Engineering and Technology, out of Huntington Beach, California. MJC Engineering and Technology, Inc. designs and manufactures custom-built CNC metal spinning equipment and specialty machinery. Let's take a look at what MJC Engineering and Technology was challenged with. Like the majority of industry machinery manufacturers, much of the equipment MJC designs and builds are complex machinery projects under contract to deliver by a certain date, putting product design on the critical path for profitability. Specifically, MJC faced the following challenges: profitability while developing complex machinery, requirements being too complex for old 2D systems, faster concept modeling and drawing creation that were needed for early design review. To maintain their global leadership, they were committed to finding a way to turn their challenges into opportunities. To better understand their pain, let's step back a bit and look at the entire design to manufacturing process for companies in the industrial machinery industry. To be competitive, industrial machinery manufacturers like MJC must adopt effective and efficient order-to-manufacture and product development processes. In our work with manufacturers in this space, like MJC Engineering, we've identified 12 key capabilities and areas that drive success. These 12 capabilities shown here are everything from marketing and selling products, engineering them to order, planning, manufacturing, and commissioning and servicing these products. As you look at this framework, what areas could your company improve in? What we commonly see is many companies are pretty good at certain areas, but they aspire to improve in other areas. MJC began looking at their current CAD solution, which was 2D AutoCAD. For them, speed of mechanical design was their primary challenge. They knew in order to reduce design errors, a 3D solution would be the key for speed and profitability. In particular, they were looking for a program that would be easy to use and also would allow a gradual move into 3D. The flexibility to move slowly into 3D was important because the company had a great deal of legacy AutoCAD data it wanted to continue to use. In MJC's case, they surveyed the tools on the market and selected Solid Edge, a unique 3D design system. Solid Edge was not just a great 3D CAD solution, but a complete 3D design and engineering package that brought to their company new capabilities and technologies in areas like sheet metal guarding and housing, product visualization for sales and marketing, as well as alignment of customer needs with their engineering department. We are going to dive a bit deeper into three that are particularly important to industrial machinery manufacturers. The three capabilities we'll look at today are reducing customized content, manage customer requirements, speed of mechanical design. The first challenge we'll look at is reducing customized content. Sales and engineering staff need to optimize the product specification to fulfill the customer's needs while maintaining and minimizing the need for customized product development. It's a balancing act that can greatly impact margin. With Solid Edge and SharePoint, you can graphically explore existing assemblies and conduct searches while retrieving existing data design. And you can also clone existing machine designs and then perform simple adds and replaces in order to modify the proven designs that you may have already made to meet new customer-specific requirements. Another way Solid Edge solves this issue is with its engineering reference tool. With Solid Edge, industrial machinery manufacturers will increase margin by minimizing customer-specific engineering. Industrial machinery manufacturers can reduce business risk by fulfilling more orders with standard predictable product configurations. With Solid Edge for SharePoint, equipment manufacturers can implement a step-by-step sales process with less need for input from the engineering team. Solid Edge enables a further benefit when introducing new staff. New staff need less training as they now follow a simple and enabled sales process. Siemens provides the technology to manage product configuration and options throughout the entire sales cycle. Staff can now select pre-configured configurations based on experience and standards. Solid Edge with synchronous technology allows the user to make precise changes to imported geometry by adding 3D driving dimensions to any geometry. Another unique capability within Solid Edge is the ability to make direct edits to imported geometry by pushing and pulling and rotating geometry with the capability we call the steering wheel. This amazing capability will automatically recognize key features, allowing powerful parametric type modifications effortlessly. As mentioned earlier, Solid Edge with synchronous technology has a patented capability we call Live Rules. Live Rules finds and applies original design intent. What does this mean to your company? It means lower overall design costs by having the ability to edit imported data and facilitate better reuse. Let's take a look at Solid Edge in action. So let's examine a few tools that Solid Edge has to offer. One of the big tools inside Solid Edge is its help system. The help environment is extensive and easy to adopt. For example, any person using Solid Edge has the ability to do things like choosing a learning path, or maybe tour the user interface. Maybe they would like to take advantage of context-sensitive help. What's that? Context-sensitive help gives the users the ability of pressing a simple shift in an F1 and clicking on a command in order to get extensive help on that specific command. If not using context-sensitive help, maybe they would like to take a very quick look at tooltips. Most tooltips inside CAD are very simple and very nondescript. We have inside Solid Edge the ability to make our tooltips extensive, reducing the need for questions. Not only are the details there, but also in some commands, videos are given. These are great tools to help the individual user. Well, besides help, how else does Solid Edge assist? Well, through quick changes. For example, in this case, what I would like to do is I would like to go into a small subassembly. Actually, I don't even have to go into a small subassembly. I can do it from the overall assembly, meaning that I am at the top level. Notice all the different subassemblies in the edge bar here. Using synchronous technology, we have the ability to go into any assembly and do things like choose faces that we wish to change. Notice as I click on faces, associated geometry, or I should say associated dimensions, pop up. These dimensions, as well as the selected faces, allow Synchronous to make extensive changes. Now watch. Not only am I making a change, but I am making a change on 4 individual pieces at once. A simple change like this in any other CAD software would take 15 to 20 minutes. We did it in less than a minute. Synchronous technology is just one tool set in the entire toolbox that Solid Edge has to offer. Albeit a major tool, other tools, for example, like part reusage. Nobody likes to have to recreate a part from scratch. So Solid Edge offers tools like engineering reference, with wizards for spur gear creation, worm gear creation, as well as shaft creation, all at the user's fingertips. If not creating a part from a wizard, maybe the user would like to access Solid Edge's standard parts library, with hundreds of thousands of parts to insert within their current assemblies. If not Solid Edge's own standard parts library, maybe the user is accustomed to online part libraries. On our splash page, we have the capability of accessing places like Cadenas or Trace Parts. At Cadenas, Solid Edge has its very own part community, with vendors from all ranges. Maybe you'd like to download something from Bimba, or possibly from Destaco, all with models directly ready to insert into your assemblies. So let's take a look at how engineering reference can assist the user in reducing design time by using wizards for part creation. As we zoom out and take a look at our gearbox, we can see that we need some spur gears to be created. So let's use engineering reference to create these missing spur gears. As I go through and change my configurations and even in-place edit into my star wheel box, we have the opportunity to place spur gears within our solution. These spur gears, maybe we don't remember all the different configuration data to create them. Luckily, Solid Edge has a tool called Binder, which allows you to link non-Solid Edge documents to our solution, and even double-click in order to obtain necessary data. For example, in our gear specifications, notice the complete data that's given within the Word document. So as I access engineering reference and go ahead and also access my spur gear wizard, I've actually already preset all the values. One of the nice things about the engineering reference tool wizards is that many of them give us the capability of doing calculations for strength validation. That way we know ahead of time whether or not the teeth will actually survive the usage of the part creation, thus giving us a passing value. With this said, let's hit Create. Solid Edge will then go ahead and create gears. Let's create this as Gear 3. As Solid Edge creates the individual Gear 3, it'll then come back and say, let's now create Gear 4. Solid Edge then will take both of these gears that have been created and actually mate them together. With the parts pre-mated, what we may wish to do is that we may wish to do something along the lines of making them a rigid set. By making them a rigid set, we have the capability of allowing both gears to stay in relationship to each other. That way, one doesn't get lost from the other as we start to mate things. For example, as I choose an axial align, I can choose the center of one of our spur gears to the shaft of one of our chunker arms. Notice how both parts move together in relationship to each other. We may also wish to add in another relationship, maybe a relationship between the back plane and another plane on one of the chunker arms. With these relationships added, we can once again come back and add in other relationships for the other parts. For example, the other spur gear, radial aligned also. I'm going to take the previously made relationship between the two gears and eliminate it with a simple delete and add the rigid sets in between the gears and the chunker arms themselves. Once more, I'll do the same here and here. With this said, we're ready to test out our design. Solid Edge has several tools that we can test out our design. Solid Edge has capabilities of creating full-fledged AVIs, as well as capabilities of manually picking apart and running it through its range of motion. In this case, let's just choose a very simple drag component. We're going to choose a radial type drag and allow the part itself to be the spur gear that we choose. We're going to choose a cylindrical handle to drag by, and using this handle we can put our parts in motion. Notice how the spur gears and the chunker arms move together, proving that our design was good. One of the biggest challenges facing industrial machinery manufacturers is the need to manage the customer's expectations with a detailed building specification. Salespeople normally focus on closing a contract with the minimal information needed to specify what the customer wants. After the customer awards the contract, engineering staff will often need more information to clarify the detailed specification. The challenge is ensuring the customer's needs are clear with enough detail for design and manufacture. The company will incur extra engineering time and higher costs if there is a misalignment. This leads to lower margins and reduced customer satisfaction from delays to machine delivery lead times. The core challenge is how to propose accurately and how to estimate the costs and lead times accurately. Sales and engineering experience conflict from over-promising and under-delivering. The challenge during the machine pre-sales phase is a balancing of time, effort, and accuracy. Solid Edge provides the technology to create and manage the standard product catalog and past product information. Engineers can now manage complete product information, including 3D designs, product configurations, and documents that were associated. Sales staff can now find and retrieve product specifications, bills of materials, and 3D representations as built or as delivered. With Solid Edge, industrial machinery manufacturers reduce business risk by proposing practical solutions which are predictable, competitive, and which can be made. With Solid Edge for SharePoint, engineers and sales staff significantly reduce the time to find and collate the information needed to propose accurately. This means staff will increase their proposal capacity and improve the sales win rate. For many of our customers, creation of the 3D model is great for new business generation. Creating the engineering model, however, produces the byproduct of 2D drawings that are required for the manufacture of the equipment. This is a common challenge for many companies because they end up using separate and disparate systems that are separated between their 3D and their 2D. With Solid Edge, this is not a problem because we have an integrated 3D and 2D system built from the ground up to maximize this capability. Not the case for all other mainstream CAD programs. We recognize most designers and engineers are under pressure to work faster and produce more efficiently. With Solid Edge, designers and engineers have a complete system to help them design better. To overcome these challenges, Solid Edge provides a complete and integrated software to make the design process faster and more efficient. Engineers can produce 3D models, accurate working drawings, and can reduce design time, eliminating design errors before manufacture. Solid Edge helps engineers speed up design and execute faster revisions and better reuse products that were previously designed. For the industrial machinery manufacturer, this means delivering sooner, invoicing earlier, lower business risk, and more opportunity to grow revenue at a higher margin. Almost every 3D CAD company can make this claim, but what makes Solid Edge unique? What makes Solid Edge unique is a disruptive technology called synchronous technology. Synchronous technology is a patented technology available only to Siemens PLM software. This innovation has dramatically changed the game in product development because no pre-planning is required. Since no pre-planning is required, with Solid Edge the user can design in a history-free environment and accelerate the design process. The user does this by focusing on the design intent versus the design tool, and not wasting time trying to predict future changes like traditional history-based systems. Full digital prototyping can be achieved inside of Solid Edge. It does this by leveraging a hybrid 2D, 3D design environment. Unlike other 3D CAD systems, Solid Edge offers a common user experience for both 2D and 3D users. We can offer this because Solid Edge was developed from inception to be an integrated 2D, 3D design tool. We understand the need to import and export 2D data and respect most manufacturing companies' needs for one common system. We look forward to showing you this capability in the upcoming demonstration. Additionally, Solid Edge gives the user freedom to redesign on the fly and respond to your customer's demands with lightning-fast speed and agility. We can do this because of other unique capabilities within Solid Edge where the system interrogates the 3D model and automatically captures the design intent. This gives the designer a more productive user experience. Accelerated design. What could this mean for your company? Get products to market faster, up to 25% ahead of the competition. In the fast-paced world of industrial machinery design, winning new business and making profit on projects can hang in the ability to respond quickly and efficiently to customer demands. Solid Edge with synchronous technology has a unique capability to allow designers and engineers to make flexible changes to models and drawings in a constraint-free environment regardless of the authoring source. Solid Edge does this by automatically integrating the engineering model and presenting the user with possible design functions seamlessly at their fingertips with a tool called Live Rules. It's like having an experienced co-pilot with you as you drive. Not only that, models don't need to be regenerated. What this means for the designer and the engineer is blazing fast performance. Solid Edge allows you to make design revisions in minutes instead of hours. For the industrial machinery industry, this means delivering sooner, invoicing earlier, lower business risk, and more opportunity to grow revenue at higher margins with happier customers. Let's take a look at the demo.
Solid Edge has other design tools to assist the engineer in achieving efficiency and reducing time to manufacture. One of those is rapid part placement. Solid Edge, within its rapid part placement toolbox, has a specific tool called duplicate components added inside Solid Edge ST7. Please take note of the referenced plates that we're going to mate our downloaded clamp. We downloaded this clamp from an online catalog. As it comes in, as I said, to take note of the reference plates. Those plates were not along the same plane, and that eliminates the possibility of being able to use a pattern for a placement. So as we finish up our placement of our clamp